in Y. Sales is explained by variation in number of sales reps, our price, and competitor's price. That leaves 35% of the variation in sales explained by something else, not those three variables. So what else can we attribute the unexplained 35%? Well, there's always random chance, and there's other variables we didn't put in the model. But these three variables explain 65% of the variation in Y. Number 11, which X variables, if any, can be eliminated from the regression model? Again, it is common to have more variables in the model than we really need. In other words, to have some variables that don't add contribute to the team. And the reason is there may be a variable or two or five that we're not sure whether it does or not. So we put it in there. We can always take it out. Or maybe the main thrust maybe the main thrust as I was saying, maybe the main thrust of the problem
should have known.
is to see if this variable is not related. Alright, so what I want to do is make two lists. I want to make a list of variables we want to keep and variables we want to throw out. I won't ask you where you got that. Okay, so that means we want to test the variables individually. So let's see, we're going to test x1, so that's beta 1. And remember, the null hypothesis is always nothing's going on, nothing's happened, non-significant, zero influence. Right? So the null hypotheses will be beta 1 equals 0, the other one is beta 2 equals 0, and the last one is beta 3 equals 0. And the alternatives are beta 1 not 0, beta 2 not 0, and beta 3 not 0. We use 0.5 for alpha. And so let's get these are t-tests. Let's get the t-statistics and the p-values. Okay, for now x1 number of people, the t-statistic is minus 0.313276. And the p-value is 0.7586898. And for x2, T is minus 2.099169, and the p-value is 0.0544168. And for x3, 2.03087.